Hi there, everyone. My name is Chris, and I work for MJH Software Services. As Morten said, for the last few years, we have been developing a cross-platform emulation of Dyalog's qWC. I'll shortly show you a video demonstrating the latest developments, mainly focusing on charts and multi-user applications. Before that, I'd quickly like to talk a little bit about Jarvis, which again Morten mentioned earlier. One of the latest developments is that qWC now uses Jarvis for static pages and file uploads. So we can now offer an APL only server end to support. Sorry, excuse me. I should do this. To support the browser, as shown in to support the browser. This means that qWC will work directly out of the box. You can still modify the parameters, such as ports and host addresses, but with the inclusion of Jarvis, the default settings of qWC will work with no setup. Optionally, you can use a more secure web server, such as IIS or Ninjix, but that's a bigger topic than I have time to cover today. I mean, hopefully there will be quite a time at the end for questions, but if anyone has any questions relating to server setup or qWC in general that we don't have time to cover, then please feel free to get in touch with us directly. The latest version of the alpha will be available for download from our website from tomorrow. Okay, so just bear with me, I'll start the video now. Hello everyone, and welcome to Charting with qWC. This is the first control that we've implemented that goes beyond qWC. We're still trying to keep it fairly similar, and further documentation will be available at a later date. So first of all, I'll just set the coordinates to pixel and turn boxing on so you can see more easily what is happening. And then we'll create a basic form, this time with the background color grey, just so you can see a bit easier what's going on. Okay, and now we'll create a default chart object. So this is all with the default values. And you can see, not very inspiring. But say this has no details in or no data to actually graph. This is just what a default object would look like if you put it in. We can then change the properties using qWS as you would with any other control. In this example, using size and position to better fill the space available. We can also add a title or a caption. We've used caption as the property name to keep it consistent with qWC and the rest of qWC. And here we can add X caption and Y caption, or captions to the X axis and Y axis, by changing their respective properties. And now we can assign some data to X data and Y data properties, and this will map the first element of X data with the first element of Y data. So January goes to 1. February goes to 2, I'm just using IO to 5. It's probably easier though to create variables and assign variables. So here we have the variable xd and the variable yd. Xd is just a list of strings, and yd is just a series of numbers. Nothing too outrageous here. And then if we assign these to x data and y data respectively, then we get this rather nice looking graph here. As you can see, the first bit, January, links up with 5 on the side here, and so on down the line. Now, the y-axis has been defined automatically by what it believes to be the best outcome for it, but you might want to set this yourself manually. This is the y-axis property. So in this case, we've put in the n to simplify that it's a numeric scale outside. The next element is a 0 to show the starting point. The third element is a 10 to show the maximum. And 1 shows that it's one step between each one shown. Further customization here, so again, n for numeric, 2, so we start, the graph actually starts at 2, goes up to a maximum of 12, and there's 2 between each one, you can see here. What about the x-axis? Now the x-axis, if we use qWG, we'll see that the x-axis is just a C. This denotes a category graph, category scale, and it just takes the various strings and displays them along the bottom. But what if we wanted to change this to x-axis to numerical as well? Well, let's create a new variable, xd1, containing some numerical data, and then if we then look to change the x-axis category to n to numerical, 0 for our starting point, and then 10 is our maximum and 1 between, and change the x data to xd1, we end up with this mess. Now, the reason it's squiggly like this and a bit all over the place is that it's trying to draw the line between the points sequentially. So going along the line like this, and it ends up going back and forth because of the numbers I've chosen. But the good thing about this is we can use APL in the background to manipulate the data. So in this case, simply sorting it by the X data. And then we can then reassign it. And we have therefore, and we then created a sequential line. So again, all the data can be modified and manipulated and wherever in the background in your APL session, and then assigned via the variables to create the graph that you want. But there are other properties available as well. So before we'll look at that, first of all, we'll reset the graph back to its original place. And you notice here I've used qWC and all the data in one long line. So you can set up these properties when you initialize the graph. I have just been changing them individually to qWS just for demonstration purposes. But this just demonstrates that you can do it either way. Now, if we want a second line, we'll create another variable, yd2. I'll show you here. It's just two sets of numbers. And then we'll simply assign this to the Y data. And there is the second line drawn. It uses the data from the XD already, the January to December, and then puts in the 2 lines using the stuff above. We can also add animation to make it a bit more flash. So here you see, and the graph is rendered, the line's animated. We have different types of graphs available. For example, here is a spline. It's a bit more curvy, maybe a bit nicer. We see an area graph, and follow this up. There are various graphs available. Here's a bar chart, for example, coming from the left-hand side, or we have column here. Now there are quite a few different types of graphs available, too many for me to show here, so further documentation will be available. This is showing you how easy it is to switch between the graphs without creating a new graph object. We can also change the type of graph. So for example, here we have a polar one in a more all-round 360 view. And this again works with line, also works with spline there. We've also got a radar type which changes slightly the display around the side as well. And we're hoping to add more types in the future that you can just seamlessly switch between without recreating the whole graph. So put this back to normal, and there we are, we have the 2 lines. But now what if you want to change the display of the lines individually? Well, if line type, if you have 2 series and you enter with 2 types, the first column will apply to the first line and the second line will apply to the second. So in this example, the green will turn to columns and the black will stay a line. There we go. Basically, it would match up to however many line types there are. So if there's 3 in a series, in this example yd3, and you see here 3 sets of numbers, which if we apply this to the Y data, here we go, then you'll see a third line is drawn. Now, for each one we define, so in this case we're defining column and line. So the first series will turn into a column, the second will turn into a line, and the third will go back to the previous one and will also be a line. So this means if you have 40 lines, you don't have to change them all, but you can change them individually if you want to. We also have the property of the show tooltip. So if we just reset the lines again, and then we apply show tooltip 1, this will then allow us, if we move over to the graph on the right, this will pop up with a little tooltip showing you the value at various points on the lines. Now we want to do a bit more work and develop more options available for this, so you could change what information is displayed there, change the types. But we're waiting until we've done a bit more work on the tooltip in other objects to see if there's some crossover there. You can see here it's working with the other line types as well, with column, for example. Goes along the line like this. And also work with the other graph types, such as radar. So you can see here again, the tooltip is showing. So this is just a quick basic introduction to the various properties that are available with charting, and we hope to expand upon it in the near future. We're now going to look at an example. This example EXC1. This is of a chart object and various other objects creating a application. This is, say, example EXC1, which you can try out for yourself if you download a copy of the alpha. And on this example, we have a chart object and then various drop-down menus that let you choose the display type and the year you want to look at. And these checkboxes on the side here let you choose which lines are shown out of the 3 products, cheese, wine, and bread. So, for example, here we're just showing bread from 2020 in column format. And then we change the line. and add extra products. And this is all updating the same graph object without having to recreate it each time. So here, change the year to 2018. And obviously this is quite useful. Now to have a quick look at the actual code itself, I'll just make this full screen for you. And you can see here, I've just made it to a coordinates pixel at the top there, defined the basic form that we work with, then just put the first set of data in. Again, it's hard-coded into this for demo purposes. Then we define the combo boxes and the check boxes, just as you would, as we've done on previous videos. Again, more information about that if you ask us. But you just set them up basically here, like you would with qWC. And then finally set the data into the chart and add the callback to the draw button. Now if we have a look at the callback, again for demo purposes I've coded in the 3 sets of data here for the 3 years. You might want to come these coming from external on an actual application. But we then use qWG to interrogate in this case the states of the 3 check buttons to create a mask. It's these check buttons down here. You can also interrogate the drop-down menus to see which year it is, and also to find out what type of line should be drawn. And then just simply use a case select to choose the right data and apply the appropriate mask. And then finally at the bottom you could redraw the data using Y data and line type, and also add a caption for the correct year. So again, this is all fairly standard APL stuff, standard callback function. Nothing too outrageous here apart from the use of qWS, qWG, and qWC. Now we're going to look at the multi-user aspect of qWC. This is where multiple instances of the same application can have their individual properties changed depending on which user is interacting with the application. So if we connect one user here in the first browser, see when it connects, the user index is set to 1. Now we can interrogate this by using the function qConnectionID, and this function returns the user index. So you see here 1, and it returns a 1. Now if we connect a second user on an additional browser, like so, then you see here the user index is set to 2. And if we run the same function, the qConnectionID function, you'll see this time it returns a 2. So this is where you can find the unique ID connection, or user index rather, for each user that connects to the application. So if we create a form here, just to show the difference, and now we have to set, in order to change that form's properties individually, we have to run the set user function. So here we see the left-hand argument is the qConnectionID, so it will return the user ID, and the the right-hand argument is just a string to identify it. So if we now connect another user here, just to show the difference, create a form on this one, this time the caption second form. You see they are different, and do the same thing where we run the MJH underscore WS set user, and now if we set the users using the set user function to a variable, so we're setting first here to P1 and second to P2, and then we can change the bcol property of the different forms by prefacing it with the p1.f.bcol to change that property, or we can change the background property of the second form simply by prefacing it with P2, since we've set that with the get user. So you see this is a simple way that you can change the properties of various objects depending on the user. We're now going to look at an example of this using our good friend Battleships. This time we're going to show a 2-player game of Battleships going on. So, okay, first of all, we'll need to run the application BS2 on 2 different users. So here we are, we'll connect the second one. There you are, so you user index set to 2, and we run BS2 code on this one as well. So we now have 2 users logged separately accessing the BS2 code. Now we've created a bit of a login screen here to help create the games. So I shall log in the first one as Chris, and then choose the host option. Now if we want to join that game, we log in as a different user, in this case Mike, on the separate connection, and choose join. Now these 2 games will now connect and talk to each other, and we end up with a game of Battleships. Each user has 2 grids on their screen. The top grid shows the placements of their ships, which are randomly chosen, and the bottom grid allows them to fire at the enemy ships. As you can see at the moment they're blank, but if you choose one cell, you can see that has changed, and the corresponding grid showing the opponent's ships has also changed on the other player. That's another miss, and then if you hit here, you see that the hit has been indicated, and it shows you which ship has been hit on the top left. And then if the player on the left chooses to take some shots, these are reflected on the grid, the top grid on the right hand player's side. You can see here how interacting with the grid on one user is changing a completely separate grid for another user. Now, let's have a quick look at the code to see how we achieve this. Again, there's nothing too spectacular here, it's mainly APL. In fact, it's all APL. If we look at the main function, the first thing to note is that we actually make use of the data property of the form in this property here, and we've actually made it into a namespace. This has many advantages, namely that you can assign several variables to the namespace, and then get access to them later on in the code. So here is an example. I mean, this is actually a defunct example because this was a workaround to correct a problem which we've now fixed. But I've left it in here because it's a good example of the namespace MFD, which is assigned to the data function of the form, and the variable JC within that namespace is assigned 0. Further down here, we've got another variable within the namespace with the login details, and then the various labels and edit boxes that make up the login screen. And then finally, we have the login button at the end, and the login button at the bottom, with the callback function bs2 login. Now again here, it's important that each new function you write, or each callback as well, you reappoint the MF qWG data to the MFD workspace. So maintain the pointers so we can then interrogate it properly. And in fact, the line below that, you see we use that data to check to see whether it is an appropriate user or not, and whether they can gain access and log in. It's also important to note that there is the MJH _WS set user function with the Q connection ID that we talked about earlier, and it also takes the text they've entered as their username as the right-hand argument. So that's setting up the set user function that we talked about in the previous example. We then, assuming the password and username are correct, we then come into this screen, which first of all it hides all the password boxes and text, because we no longer need that, so we set that to visible 0. We then set up the 2 buttons, host and join. We're actually repurposing the login button for the join here. We then set the events for host and for join. If we look at host first, again at the top we have to set point to the namespace from the data, and here we take the username and assign a 0 to the opponent. Now, that's important. Hide the other buttons that we no longer need, the 2 buttons, and then we check to make sure, see if there is actually a already existing list of games, create a new one if we haven't, or add our username to the list of awaiting hosts if it already exists. We'll then come down here, and then we then sit on this delay, and we basically sit on this delay and we wait, our computer waits until the property of our opponent is updated from the 0 we set it to initially to an actual opponent. Now this is done in the other function, which we'll have a look at now. So when you click on the join function, come in here, again, same thing, set the namespace at the top. There's the JC that we were talking about earlier, which is actually serves no purpose now, but I haven't taken it out of the example yet. And below that you have make the login buttons invisible, visible 0, like you did in the last one. And then below that you check to see if there is an existing game, and you take that the username from the host list that was provided by the host function for the other player, and you set that to your opponent, the mfd.op variable within the namespace. Then then further down, you would then use the get user function that we talked about earlier to set up using the opponent you've selected from the host list and setting up their user connection and assigning it to OP. You then use op.mf.data.op to assign your username to that variable. And it will then stop the loop that's happening on the other player's computer with their host, and both computers will then run the new game function. If we have a quick look at that now. Again, setting the namespace, assigning namespace at the top, and then we have got a function here that randomly generates the positions of the ships. I wouldn't worry too much about this. Again, this is all in previous examples. We've been over this, but it's basically a bit of APL just to randomly place the ships each time, so that you have a different game experience. We then set up the two grids, your grid, which will just where you can pick the shots, and your opponent, and the grid that shows where your ships are. The important property on this is probably the cell types, which if we just scroll a bit along here we'll see. And basically as the cell types change, then they will change the colours of the various cells. There's also needs a callback function added to the bottom grid, so when you click on the cells it changes the colours and changes the cell types. This is this callback here. So if we have a quick look at this, again set the namespace at the top, and the event message, the 7th and 8th element of the event message will denote the column and row of which cell was clicked on. And we can also set up our opponent into the OPP variable using the get user function. Then we've also got here the MJH_WS.log. This is just another function that records a log of what's going on in the browser, which you can access, and it's useful for debugging. And down here we then get the cell types by interrogating our grid and the opponent's grid. And then depending on whether it is a hit or a miss, we update the cell types of that particular cell to the correct number, and then we change reset the cell types to that variable, both firstly for our grid and then for the corresponding opponent's grid. We also keep track of which cells have been clicked on, so that we don't run the code unnecessarily multiple times. So what next for qWC? Well, in the short term, we want to emulate qWD. This means you won't need to use delays like the one seen in the previous example for multi-user applications. We also want to make multi-user easier to use by replacing the getUser, setUser, and qConnectionID functions with something more user-friendly. We will continue to add new controls, some emulating qWC and others that go beyond qWC, like the chart control shown earlier. We'll also continue to making improvements to the speed. We've already seen major steps forward in this area, and you can see this if you compare the response time of the grid a few months ago as demonstrated at a BAA meeting, and compare that with the response times now. I'd also like to show you a chart with 1,000 reference points on it, so you can see how quickly this is created, and also show you a chart that updates randomly every 0.1 seconds. We can reduce this artificial delay to 0.01 seconds, and it still responds as expected. There's still some work to do for even larger charts, and to iron out some problems such as the flickering you can see at higher refresh speeds. Thank you for watching, and we'll now be available live to answer any questions you may have.
Well, I have a question. Do you have a list of qWC or qWC controls that are supported and a roadmap for?
We don't have a definitive list as such at the moment, because we've been working on adding controls and increasing speed. But one of the priorities going forward after this conference will be to improve our documentation. So basically, it will be available very shortly. It will probably be my priority task after this conference. So watch this space. Yes, there will be some more documentation available very soon.
Yeah, I mean, for me personally, the list of controls, and then within each control, the list of properties that are actually
Exactly, yeah.
Basically, the delta, the list of differences between qWC and qWC is.
Yes. Well, kindly, Dyalog have actually given us access to the qWC documentation. So our plan is to actually use that as a basis, and then to highlight any differences between the two. So you'll see directly. I mean, most of the documentation should be based on qWC, as this is an emulation. But so there will be some differences, and there are some properties which have higher priority over others. So basically, it'll be a living document that we update, and gradually it will just match the same as the qWC. But we'll be using a color code scheme to denote what's been implemented, what we plan to implement, and anything, very little, but there's a few things we plan not to include. There's also as a priority, say the chart I showed earlier, that obviously doesn't have any documentation of qWC because it's not a qWC control. So any of those ones we'll obviously have to document, but we intend to do in a similar style. And we intend to do them as a priority. So at least you'll have something to look at if you want to try this out for yourselves.
There's a very good question from Madame, which I totally relate to, having tried to build web applications in the past. How do you deal with errors in invalid properties? Because in many web frameworks, that just leads to weirdly dysfunctional user interfaces.
Yes, I mean, there will be. I mean, we have certain processes or methods in already which will look for, like, say, invalid property names and things like that. We do need to expand this a bit as we add more controls and as we add more content to qWC. But there should be controls at the APL which will tell you if you've put in something that's not recognizable. But yeah, that's certainly an area we need to add some more stuff into as well, I would say.
Yeah, I mean, in playing with it as I have for the last few weeks, I did notice a number of cases where if you set a non-existent property, just nothing happened, no error message, it just sort of didn't do it.
I think some of those properties may not be quite as the ones you were playing with, maybe quite not be so robust because we were pushing them in quickly for you. But yeah, certainly, I mean, the speed of development of this has really stepped up recently, and I think we do need to have a bit of a consolidation and make sure things like the error capture and the documentation is as solid as it needs to be for full release. But yeah, it certainly is something we're aware of and we're working on. I don't know if Michael wants to say anything more about that or.
Right. Well, with 1 minute to go, there's a question about pricing.
Well,
is this a commercial product? Asks Neeraj.
I mean, at the moment, it's very much an alpha. If you're interested in trying it out, best thing maybe to get in touch with us. It's available from our website. I say the new version will go up tomorrow, so I'd wait for that. In terms of going forward, we haven't really considered how we would deploy it commercially, or at least not anything we'd like to discuss publicly. But certainly our aim is to be released in some form or through some kind of vehicle.
Okay, I think we're out of time. Thank you very much.
Thank you very much, everyone.